Okay, so in the previous class we did 15. In this class we will be doing the 16 and 20. Okay, this will be on page 137 and 20C will be on 138. Okay, so let's start with 16, which is on page 137 to 138, I think. Let me read. 138, this also is 138. A and B are on 137. A and B are not numerical. Okay, it's a part of explanatory question answer. So let's go to numerical because we are doing numerical tests. Okay, let me read the question there. 9C. A boy of mass 60 kg running at 3 meters per second. Notice the second one, I think, 9C. 16, sorry, 16 is on page 137, sorry. Slight correction, 137. Now, an object of mass 100 kg is accelerated. So let us object like before. As I said, this is not absolutely necessary, but it helps us in understanding it clearer, because physics is such a subject where if you put some imagination and assumptions, it becomes easier to understand. That's why I'm doing this. Let the object be moving from left to right. Assumption, this is moving, means original direction from left to right initially. Okay, so then we go there now. Object mass means mass of the first. Just write. Maybe any way you can do it, but like this also we can go, since the particular object moving from left to right of mass 100 kg is accelerated uniformly. This is important. Only when it's uniformly accelerated that we can use the formula for motion and all, because the formula derived there is for uniformly accelerated objects. Okay, from velocity of 5 meters per second, this is fine SI unit, to 8 meters per second in time of 6 seconds. So this has got some informations that we're going to need. So here we write, here as we read this statement of the question, mass of the object, let us say mass is equal to 100 kg, right? Mass is equal to 100 kg. Initial velocity means the first time when the object was seen in the question is 5. First appearance is the initial velocity. So we write here initial velocity, and final velocity is v. After some time it is accelerated, means increase in velocity to 8. This is the final velocity. And then to increase from a speed or initial velocity 5 to 8, it took a time period of 6 seconds. It takes time to increase the speed, right? So you have v, u, t, m, everything, and we have to find, let us see the question. Calculate initial and final momentum. So let us just first find out the one, initial momentum. As we learned in our previous class, under momentum is simply mass into velocity. Initial means u. So that will be equal to 100 kg is SI unit, that's fine, into u is 5 meters per second. So this will be simply 105 kg meter per second. So this is the first answer. Then the second answer is, they're also asking final momentum, I think. So find the initial, calculate the initial and final momentum. So final momentum. The next part of the question that we need to answer, mass of the same object into its final velocity, because this final mass is 100 kg and the final velocity is 8 meters per second, I think. So 100 kg into 8 meters per second. As you can see here, the v value is 8. meter per second to be precise. 100 into 8 is 800, then here kg meter per second. So this is your second answer. Now we have also got to do something. Find also the magnitude of the force exerted. So we know, since formula for force F is simply mass into acceleration, the common formula, and which we know can be expressed as mass into acceleration is v minus u divided by t, as we have been explaining often here. The first equation, v is equal to u plus at like that, and v and plus go this side, minus u, then t, a you keep it, and if you shift t into means it will come down, so a is v minus u by t, so we're replacing by that. Again, just explaining, okay, so we don't get confused. Mass is 100 kg, that of the mass. Final is 8 minus here. U is, we can just put bracket on the numerator, that's enough, I think. Denominator also fine, but we don't need it. So here, and 5, U is 5, and meter per second can come out as common. Divided by T is 6 seconds. As you will see here, VU, 8 minus 5. So this will be 100 kg in the simple case of 8 minus 5 is 3 meter per second. And then if we shift this up right here to numerator, second to the power plus 1 will become second to the power minus 1. Simple case, right? So this will give you here m into a. So divided by 3, by 6, we are forgetting this one. So if you do this, 3 2s are 6, then 2 5s are 10, 0. So we're going to get here 50, right? And then here kg, be careful with the unit, meter only 1 into second to the power minus 1, and minus 1 means the power minus 1 will add up like this. Minus 1 is minus 2. So second to the power minus 2. So this is correct because the SI base unit of force is F is kg meter per second square, which in honor of the scientist called Newton, we can write in short as kg meter per second square. The base unit can be written in short as N, representing Newton. So we can write here, which is positive plus. Clearly it is plus 50. Right, so our answer for force exerted. First answer, this one, initial momentum, final momentum, and force exerted. By what? Force. Let's go there now. Force exerted on the object. So, therefore, force F exerted on the object by this 100 kg mass object. Force exerted on object to have this high velocity from uniformly accelerated motion from 5 to 8 to increase from 5 to 8 meter per second. How much force exerted? That's what the question is asking. Force exerted on the object is 50 Newton. So 50 Newton force have been applied to increase the velocity of this 100 kg mass from lower initial velocity of 5 meter per second to 8. You need a force, right? So increasing. So 50 Newton, comma, in the original, because it is plus, original direction. That is, the force is applied from left to right there. When the object first appeared, we assume it was moving from left to right. After the force is applied also, it's still moving from left to right because it's plus. This is correct because the velocity is increasing from 5 to 8. So it should be, force should be applied in the same direction to increase the speed. If you want to stop, then you apply in opposite direction, and it will be 5, not 5 to 8. It will become higher to lower, 8 meter per second to 5 meter per second, then the value will come out negative. We know that by now, right? So this is the third answer. One more question and then we can give the test. That is question number 20C. This you will find on page 138. 20C because A and B are not numericals, okay? So, and we are doing only numerical parts as tests right now in these classes. Let me go to page 138 and let me read the question once. I hope you're getting it. Okay, keep it simple and it's not so hard. Okay, if you discipline yourself and go through like this, through all the tests, you will realize every numerical is done, because we are doing every numerical inside the chapter as well as the back of the chapter. We're trying to do almost every numerical. Okay, so a boy, page 138, 60 kg running with, okay, a boy 60 kg running with at 3 meters per second jumps on a trolley. Okay, so here trolley 140 kg moving with a velocity of 1.5 meter in the same direction. So since both of them are in the same direction, let us assume let both the boy and trolley, which is moving in the question itself says they are moving in the same direction. So let us presume the direction to be, let both the boy and the trolley be initially in the original state moving from left to right. We must understand that they are not moving together but separately, but both in the same direction, okay, before collision. What is their common velocity? Jumps, after that the boy jumps on the trolley. So we can write here, here MA, mass of the boy 60 kg, and MB is the 140 kg, are the masses of the boy and trolley. Trolley means that it has wheel, and if you jump on it, it will move along with you, right, respectively. Then as you read on, boy was running with initially 3 meters per second. So initial velocity of the boy, UA, is 3 meters per second. And trolley was moving with velocity in same direction as the boy. So initial velocity of the trolley, 1.5. Both of them is same direction is plus plus, left to right is plus. Are velocities, or you can write initial also up to you, velocities, no also okay, of the boy and trolley respectively before interaction, means before the boy jump on the trolley, before the boy touch the trolley by jumping on it. Okay, what is their common velocity? So after jumping, the boy will move with the same velocity as the trolley. Both of them will have same velocity. Let's say V is the one, is, let's say, common velocity. It means both of them together after interaction. This, we have to find this. Okay, so let us write down here. Do slowly. As I said, give yourself a lot of time to think. Okay, and yes, don't hurry. Okay, don't hurry. So total momentum before or after, whatever you like, interaction. Before means the boy jump on the trolley, will be mass of the boy, MA, in the initial velocity of the boy, UB, mass of the trolley, MB, in the initial velocity of the trolley, UB. MA is 60 kg boy, into its velocity is, I think, 3 meters per second, plus mass of the trolley, 150 kg, I suppose, 140 kg, into its velocity was 1.5 meter per second. Let me check once. Yes, that's correct. So here 3 6 are 18, so 180 kg meter per second plus this 0. If you multiply here, 10 means decimal move and no more decimal in 1.5. Multiply that to 14, then 4 5s are 20, 6, 5 and 1, so 0, 11 and 2, 210 kg meter per second, as we can see. Right, so we get that one. So if you combine these 200, 380, 390 kg, and common unit is same, see, this is the unit of momentum, so it's correct, 1. Okay, so next, similarly, total momentum after interaction. Let us say interaction means after the boy jump on the trolley will be mass of the boy ma into final velocity common v, mass of the trolley, and here also v, because after jumping on the trolley, the boy is on the trolley, so both of them will have the same combined velocity, so ma plus mb, and then you can take this common v in front or back also, like your text is doing, then back. Okay, and then here 60 kg plus 140 kg is that of the trolley, and v we don't know yet, so let us put this one as a question number 2. They're asking us just the combined velocity, I guess. Yes, so we have to calculate that. So we're about to complete, so patiently. Now according to the law of conservation, according to the law of conservation of momentum, right, conservation of momentum, we have learned and even proved numerically that total momentum before interaction or before collision, whatever word is more appropriate, we're using according to the question that we're dealing with, right? So that will be equal to this side, total momentum after interaction or collision, after interaction or collision, we can say. So now it's just a matter of putting the right values properly in the proper position and solving it. So here total momentum before is, if you see here, is the word before this one. So it's up to you whether you write this left or right. Okay, 390 kg meter per second will be equal to after one is this one. We know that I've wrapped it out here. So this one, one more step, sorry, just in between you, I forgot to add. We can add there also, but it's better to add it here. I think 260 plus 140 kg into v. This is equation 2. Go back and remove the 1, 2, and this one is 2. So after is this 200 kg into v. We write here, since using equations 1 and 2, we mean to say this 390 we're getting from equation 1, for this we're getting from equation number 2, 200. Okay, so here it's just a matter of we need to find v, so just keep v on its own side, then 390 kg meter per second is not shifted, so same place. If you shift this into, will go down to denominator and become divided by. Just do slowly so that we don't miss it out. Now I think this is the smart way of doing it. 0, 0 cancel it and try to make this one as 10, possible or not. Yeah, that way then don't cancel the 0, it's possible, I think. If you don't cancel the 0, meaning you can cancel the way you like it, but if you think and cancel a little bit smartly, then saves time. That's why I'm saying, okay, so here can you make this one followed by like this? Let's see, I think possible. 2 1s are 2, 0 0. Why? Because this is so easy to divide, that's why we're trying to do that. Then 2 is also going here, that's why I'm doing 2 1s are 2, 1 in hand, 19, 2 9s are 18, 1 in hand, 2 5. That way it makes your job easier. So here 2 0 means decimal is here 1, and 2 it'll become 1.95 because of dividing by this 2 0. Then kg cancel. Meter per second, that is correct, is the unit of velocity SI unit. So this is V. So you can write your which is positive plus. That is important. Go back to question. What is the common velocity? So you can write the final step, final answer. So you write here after flowing this. Therefore, common velocity, which is V, or common velocity V is 1.95 meter per second, comma. Because it is positive, we write here in the original. Both the objects were moving from left to right. Still, after calculating, still plus means still left to right. Original direction, that is still from left to right. So this is your final answer, common velocity. That concludes the part for this 9E. Now you can go and give the test. Every test is numerical test in physics is such that question word by word is identical. Only thing is 8 meter per second may have been changed to 5 like that. So it is designed in such a way that it's not hard. It's more for you to practice after you understood. So don't miss your test, okay? Okay. Because if you take what I'm saying seriously and sincerely and do it, you'll find it that it's not so hard, okay? Over a period of 1 month, 2 months, you'll see you have, without even knowing, you have improved so much. Okay? So thank you.